All right, let's look at the homework 9.3, problem number 6. All right, so we're going to use the change of variable given here to turn a non-separable equation into a separable equation. Then we solve the differential equation from there. All right, so let's do that. All right, so first we're going to start with substitution, which is given here. Right, then I'm going to go ahead and take the derivative with respect to x. So we'll have du over dx is equal to, right, derivative of x is just 1, and derivative of y, I'm going to write the y prime. Right. So I'm going to solve for y prime. So this is going to be just subtracting 1. We have du over dx minus 1 is equal to y prime. Right? Now we have an expression for y prime. So I'm going to just plug this guy right into the original differential equation here, right? And also, by substitution, right hand side is actually just going to be u, x plus y, right? So we get, so the differential equation becomes, let's see, 14, right? So y prime is now, can be rewritten as du over dx minus 1, and this is going to be equal to u. All right, then I'm going to divide through by 14. So we have du over dx minus 1 is going to be equal to u over 14, and I'm going to add 1 to it. So we have du over dx is equal to u over 14 plus 1, right? By taking the common denominator, we can rewrite it as u plus 14 over 14, right? So let's separate. I'm going to put all the u's on the left and everything else on the right. So we can divide it through by quantity u plus 14, right? So we get the 1 over u plus 14. Then we have a du over dx, right? Then what's left is just a 1 over 14, right? Then we take the integral with respect to x on both sides. We get, right, natural log of absolute value of u plus 14 is equal to x over 14 plus some constant c, right? Then, to get rid of natural log, we can raise e to both sides. Then you get absolute value of u plus 14, right, is equal to e to the, actually I'm going to call this guy c1, x over 14 plus c1, which can be split into e to the c1 times e to the x over 14, right? Then we can take the absolute value sign by doing this. So I'm going to take off the absolute value sign by putting a plus or minus there, plus or minus. And you see that here, since plus or minus e to the c1 is just going to be a constant, I'm going to use c for that. So this is going to be simply c times e to the x over 14. Right? So we have that. Then we can just subtract 14 from both sides. We have u is equal to c times e to the x over 14 minus 14. Right? Right, remember that the u is originally x plus y, so this is going to become, so I'm going to come up here, right, x plus y is equal to, so I'm writing that instead of u, then you have a c times e to the x over 14 minus 14, right? Then I'm going to subtract x, so that I can isolate y, so because y is the solution. So you have a c times e to the x over 14 minus x minus 14, right? And that's the solution of the differential equation, right? So let's type it in. Alright, so we got y is equal to c times e to the x over 14 minus x minus 14. Alright, so submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.